In this example, we're going to conduct a test for homogeneity for the claim that the two different populations have the same proportions of the following two characteristics. So we've got a population 1 and a population 2 and characteristics A and B. So this could be eye color and hair color, for example. What I'm going to do is take these into a spreadsheet and show you how to get the rest of the tables in here. So the first thing to do is calculate the sum of each row and each column. And I've got the sum of each row. I want the sum of each column as well. Now 159 is then the total number of people that were surveyed, or whatever situation we're talking about here. So in other words, the 4 original data points that we were given, those all add up to 159. The rows add up to 110.49 and the columns add up to 56 and 103. So now to calculate this second table that they're asking, the expected value of the observations, the way you do that is, suppose I'm going to look at this as my table, those 4 boxes. So in the top left, that is going to correspond to the top left in the original data. So what I do is, for the top left, I take the top row, I multiply that times the leftmost column, because that is where the top left value comes from. So it's the top row and the left column. Multiplying those together and then dividing by the total, the 159. All right, now for the top right value, I'm going to take the top row sum multiplied by the right column sum divided by the total. And the bottom left will come from the bottom row sum times the left column sum divided by the total. And then finally, for the bottom right, I'm going to take the bottom row times the right column sum divided by the total. And these are the values for my expected table. So let me plug these in, rounding to probably 1 or 2 decimal places. Let's go to 2 just to be safe. Let's call that 6. I'm going to take this one to 12.2. Oh, sorry, 17 rather. 0.26. And then this last one will be 31.74. Okay, now we need the residual table, this O minus E squared over E. So we have our O table, which is this first one. We've got our E table, which is this one, the expected values. But now we need, I'm calling this my residual table, and that is, in parentheses, I'm going to say the top left minus the top left of my E table squared divided by E, again the top left E again. So for my residual table, I'm calculating the top left corner, so that's why I focus on the top left boxes in each of these, the observed and the expected tables. And now I can drag this to the right one, and it will know to calculate the top right residual. And then if I drag the box down to fill in, now I've got the bottom row for my residual table. And I can fill those in. And I'll take this to maybe 3 decimal places just to be safe. 132.072. 0.295 and 0.16. Well, it really complains when I don't put a leading 0 in there. 1. And then finally, it's asking for the chi-square test statistic. That is the sum of that final table. Sum of all those values. So I use the sum formula, and it gives me 0.6591. And I see here it's asking me to report all answers to 3 decimals. So let's go back up here and put in a few 3 decimals. So this should be 5, 8. Probably would be okay. 5, 8. And this one will be 3.742. Okay. Now, if I had to calculate the p-value, I would use the chi-square.dst.rt for our right tail. And the first thing it's asking me for is the x value. That's my test statistic. And then it needs the degrees of freedom. The degrees of freedom are the rows minus 1 times the columns minus 1. So in each case, it's 1 times 1. That means my degrees of freedom will be 1 in this case. So there would be my p-value. And instead, if it was asking me for the critical value, let's say I'm dealing with a 0.05 significance level, I would use the chi-square.inv.rt, and I would plug in my significance level first, and then my degrees of freedom. If it's a 2 by 2 table, my degrees of freedom is a 1. And there's my critical value. And see the green and breathe a sigh of relief.